Hello everyone, hope you are doing well. So today I'm recording the session for one of the most important interview questions, which is a difference between atomic classes and volatile keyword. Okay, they both come in multithreading. Okay, so we have to understand what the difference both of them, right? As many developers do not get a chance to work on it, right? So they are not too much familiar on it, right? In frequent. So I'm just giving a clear picture of it. If you're preparing for the interview, that will definitely help you to crack your interview. Okay, so let's understand atomic classes and volatile keyword. So first I'm going directly with the difference. Okay, then we will understand that implementation of it as well. Okay, so let's come to the directly with this difference. So what the difference between atomic classes and volatile keyword? So let's understand with the volatile first. So what volatile is that? Ensure visibility of the changes to a variable across threads. Always read write directly from the main memory, right? So volatile always read and write, perform the read write operation from the main memory, okay, and it will always ensure that visibility, right? Ensure the visibility of the changes to variable across threads. Always read write directly from the main memory. What it does not do, does not make compound operation atomic. Compound operation, we know, like kind of mathematical operation like increment or decrement, kind of that, right? Like counter plus plus, counter minus minus operation. So whenever you have a something increment decrement operation, that cannot be done by the volatile keyword, right? And it does not prevent the race condition. So I will explain race condition as well. What is race condition? But always remember that volatile cannot prevent the race condition. When you need a simple flag variable shared between threads, right? So whenever we have a like simple thread flag variable which I want to share between multiple thread, then only you will use volatile keyword, right? So what is the meaning of this visibility and all? So let's give understand the clear picture of it. Okay, so what does it mean here? So I have designed one program that is for volatile first. Okay, so before volatile, let's understand the race condition. As one terms come here, right? That volatile does not prevent the race condition, right? Wherever in atomic, right? If you can look on the atomic also do the same kind of things only, but it does prevent the race condition, right? When to use? When multiple threads update variables like without explicit synchronized block. So whenever multiple threads want to access it, right? That time we are going to use this atomic. So atomic, what does it do? It does provide atomic operation, right? Thread safe and lock free operations like increment and get and compare and set. So these are the two methods actually. So atomic, these are the some classes like AtomicInteger, AtomicBoolean, like atomic array list. We have like different type of classes of it which we can use. That will always call two method internally, increment and get first and compare and set. So that means it is performing like two operation, compare and swap. So it will, how does it do that? Internally to use compare and swap at CPU level. Use case when multiple thread are updating. So what could be the scenario where I can go with the atomic or this one volatile? So here you can understand one thing here. Suppose I have one resource. Okay, let me present you one example here. So I have one example like counter. This counter I'm going to share between two threads. So I create one more example here, one more class here. One is a counter which is having a count equal to 0, and I'm calling one increment method, and that is doing count plus plus. Now let's go to this implementation of this which is a race condition example. Okay, race condition demo here. So what we are doing in the race condition demo, we are calling this, we are having a first we are getting the object of this counter class, right? And we are calling this in two different places, right? Counter.increment and counter.increment. So counter.increment, what happen, right? It will perform, it will call 100 times, 1000 times, sorry. It will call thousands times and it will increment the value of count will be 1000. Then again it is again running 1000 times, so it will also increment the value of the 1000 times. So the exact result of this program which I will get, that could be 2000, because the count variable which we have, right, here we have initialized with the 0. So if I will run this code, right, thousands time it will perform that increment, it will call the increment method. So every time it will perform, it will call count plus plus, right? And here it will increment again, it will call, so here also it will do the count plus plus. That means thousands time it will also update. So the final result should be 2000 for me for every iteration, right? But let's see what the output of it. So at first execution I am getting 2000, okay, which should be the right values. If I will rerun this once again, I'm getting the less value. Okay, let me rerun this. Again, I'm getting the less values, right? So what happened right here, the exit result should be 2000, which should be always same. But here I am not getting the exit result. So that is one of the biggest problem. That is only called the race condition. So race condition always will say that program output will not be correct. When it will happen, when we are sharing one resource between multiple threads. So counter class I am sharing between two threads, thread 1 and thread 2. Both are updating the values. So how it is happening, why it is happening? Now let's understand with one of the diagram. So it is the one diagram. So here we have a two CPU, CPU 1 and CPU 2. One is using thread 1, second one is using thread 2. And here we have main memory is like counter equal to 0. So here we have a CPU cache and CPU cache. Both thread are having a CPU cache. So that time what happened, right? It may be possibility CPU 1 cache having a different value and CPU 2 cache having a different value of counter. So if we having a different value, right? So with race condition what happened, right? It will directly read the value from the cache itself. It will directly read the value from the cache itself. So it may be possibility sometime I may get 7 and sometime I may get 0. But the exact value which we have in the main memory, there is a 0. So the output should be here 0 only. Output should be 0. So race condition what happened, right? Race condition will always say that the data should be read from the cache itself, not from the main memory. So that time I will get, because it is having a different copy of the cache, so I will get the different output of it. Same I am getting here. So when I'm running this program, right, sometime I'm getting 2000, sometime I'm getting 1976, sometime it is a less. Value also cannot be fixed. So whichever they are having in the local cache, that it will return it, right? So atomic is a one class, atomic integer or atomic having like one concurrent package on it, right? So it will help you to prevent the race condition. So let's understand first atomic, then we'll understand the volatile, and then we will compare both of them, or we will differentiate both of them. So first we have to understand what is the race condition. Now I am going to explain you what is the atomic. Okay, so let me run one. I have already designed one class having atomic integer, and here we are having some class, like for example here in the previous scenario we took a count simple, but here I am taking atomic integer class. So atomic integer class is a part of concurrent and atomic package, right? So what does it do? It does avoid race condition. So how many atomic we have? Let me show you that. So here we have like atomic integer, we have atomic this one boolean, we have atomic long, we have atomic long, atomic boolean, atomic integer, atomic integer array, okay, atomic integer file update, long array. So that type we have n number of classes under this atomic package. So depending on your need, we can use, if it is a boolean type, flag type, we can go with the boolean. If it is an integer type, we can go with the integer. So this time I am taking the integer only. So here I am going to take count, and here it is initializing with the 0, and it is also doing the same. And here we have a method called increment and get method. So increment and get is a one method of this atomic integer only, which is updating the value and performing the atomic operation. Now I am using this class between two threads. So here I am going to use this atomic integer demo class. So what I am doing here? We have used thread 2 class, thread 1 and thread 2. Same thing. Running this 1000 times, running this 1000 times, right? And what happened right here, we are calling start method and we are calling the join method, and here we are displaying the final result, right? Now let me run this code. It is the same that we are doing in the race condition only. So let me run this code. I am getting a 2000. Now let me rerun this. I am getting 2000. Let me rerun this. If I run this n number of time, right, that time it will give me 2000 only. It will not give me less than that, because here it is preventing the race condition, and it is saying that, okay, if it is updated once in a main memory, right, I will not get from the local cache. So that only it is saying in this diagram. If I am using the atomic, right, atomic will always say that I will read data from the main memory, I will not read data from the local cache. If it is non-atomic, if it is a simple variable, that time it will read directly from the local cache itself. Okay, so that is the main purpose of atomic. Okay, so first we have understood race condition, right? Then we have understood the atomic. Atomic does prevent the race condition. So mainly use of the atomic is prevent the race condition. That's it. Okay, and it will used whenever we have like shared in when we are working with the multi-thread environment, right, without synchronized. So it will provide one kind of thread safety. That is provide one kind of thread safety. So that is the atomic. Okay, now let's understand volatile. Okay, atomic is clear now. Now let's understand with the volatile. So what is a volatile? Volatile keyword in Java is used for thread safety and visibility of the variable. It is also do the same kind of things, right? So the volatile keyword is used for the thread safety, that is also used for thread safety and visibility of the variable, right? What it does, when a variable is declared volatile, it tells the JVM that always read the latest value from the main memory. So that will also do the same kind of things, not from the local cache. Always write update directly to the main memory, so other threads see the changes immediately. This ensure visibility of the changes across the thread. So volatile does use same like a atomic, but there is one difference actually. When do we go with the volatile and when do we go with the atomic? Because atomic is also use the same like read the data from the main memory, not from the local cache, right? That is also for the visibility purpose only, right? So what is that? Volatile cannot be fit and atomic will fit. So I can say that atomic is having a like broader version and volatile is having some kind of limitation. So now let's understand with this difference here, right? So there's two things, atomic operation and prevent race condition. So one thing that volatile does not do that, it does not prevent the race condition. Visibility is fine, that will do by the volatile, right? Visibility will do that, but it does not prevent the race condition. So that means for any mathematical operation, for any count plus plus operation, volatile is not preferable. Volatile only will preferable whenever we have a simple kind of flag operation, like true or false kind of operation. That time volatile is preferable. Atomic is preferable for all the scenarios, whenever you have flag operation, whenever you have like a increment decrement operation, kind of that. It could be in any scenarios. So that is the difference between volatile and atomic. Volatile will not be work whenever we have mathematical operation. So for atomic operation, volatile does fail. It does not prevent that. So that means it does not provide the race condition also, right? Both does read the value from the main memory, right? So I have designed one example for volatile as well. Let me show you that. So here I have like one flag, something I took it in volatile. So there is a one shared resource, and here I took a one variable like flag type variable like boolean type. So I'm using here volatile. So volatile added here, right? And it is simply doing the kind of stop operation. So for start stop operation, it will fine. But if it is having a frequent increment operation, right, that time volatile will not be filled. So I can't try here, right, count value variable, count equal to 0 or something like that, because count is doing frequent operation, right? Increment decrement operation, it could be any operation. On that time volatile will not be fit for that. Volatile only will use whenever we have a flag kind of operation. So the simple crystal clear difference between volatile and atomic. This is one of the most important interview question which is asked in a actually asking in a day-to-day. Okay, so please watch this completely, and definitely that will help you to crack your interview. Thank you so much guys. Thanks for watching. Take care and bye bye.